All right, here we are ready to start Unit 1. So Unit 1 is all about graphs, functions, and models. And we're going to start it off with our first section, which is an introduction to graphing. And I called it a review because I'm pretty sure most of the topics in this section, and there are a lot. There's several things we're going to go over in section 1.1. And so I broke it down into like 1.1a and 1.1b, just so that we're not having to go over massive amounts in just one homework section. Okay, so what we're going to focus on in this one is plotting points, which hopefully we all remember how to plot points, determining if a point is a solution to an equation. I want to go over graphing using x and y intercepts, and then graphing using the slope-intercept form of a line. And we're also going to look at the distance between 2 points and the midpoint between 2 points. Okay, so none of these topics are overly overwhelming, hopefully. So we're just going to do them all in this section. Okay, so let's kind of go over the basics. The basics of plotting points is we need to know our x-axis. Obviously, our x-axis is our horizontal axis here, and our y-axis is our vertical axis. Okay, and then quadrants are the 4 areas of the graph that are created by the x and y axis crossing. Okay, and we label them with Roman numerals. Okay, we always start where x and y are both positive. So really quickly, when we talk about where x and y are positive, okay, since this is our x value, right, and our origin is this very center point where x is 0 and y is 0. And the x's that are in this direction are positive, right? This is our positive 1, 2, 3, 4 on out to however far we go, right? And our x's going this direction, that's our negative direction x's, right? And the same thing with our y's. When we look at our y's that are going upwards, those are our positive y's. And when we look at our y's going downwards, that's our negative y's. Okay, so y is in relation to our vertical axis, x is in relation to our horizontal axis. So when we talk about where x's and y's are both positive, that's this first quadrant. So this is the quadrant that I'm going to label with a Roman numeral 1, and it has to be a Roman numeral. Okay, can't use a regular number. It's like a thing. Okay, and then when we count the other quadrants, 2, 3, and 4, we actually go counterclockwise. So this is quadrant 2. This is quadrant 3, and this is quadrant 4, okay? And then we express every point on a graph as an ordered pair, where x is always our first coordinate and y is always our second coordinate, okay? And I already said the origin on our graph here is the point 0, 0, right, which I have marked here, okay? So let's go ahead and look really quickly at being able to plot points and then being able to see if a plotted point is plotted in a certain quadrant. Okay, so just kind of applying this basic knowledge that hopefully we've seen before. All right, so a couple examples. This one says, plot the given points, label with the given letter, and state the quadrant of each. So we have letter A that we need to plot, and it's supposed to be at 6, -4. So remember, our first coordinate is our x, and our second coordinate is our y. So we're going to go to where x is 6, which is right here, right? And then we're going to go from there down to where y is -4. 1, 2, 3, 4. So this is where we're going to plot our point A. And notice that falls in this quadrant down here. Remember, this is the 4th quadrant because we start here with 1, 1, 2, 3, 4. So this is in quadrant 4. Make sure you write it with a Roman numeral to represent the quadrant. And then we're going to do the same thing for B. So B wants us to plot 0, 9. So here my x is 0. So that would be right here, right at the origin. And then we're going to go up to where y is 9. So we go up to where y is 9. Then this is our B point, okay? And that actually happens to fall right on the y-axis, right? This is my x-axis, this is my y-axis. So if it asks for a quadrant and it's not in, either 1 or 2, right? It's between, it has to be lying on an x-axis or a y-axis. So I'm going to go ahead and just mark that out, and we're just going to say this is on the y-axis. Okay? All right, the other thing that we should be able to do is if we see a point that's graphed, we should be able to come up with the ordered pair ourselves. So if we're looking at this point C, what I really need to know is I'm looking to see what's its x value. So if I look at its x value here, that's at -4, right? So I'm going to write in -4. And if I go up to its y value, that's at 7. So this would be the point -4, 7. And notice it's falling in the second quadrant, right? So this would be quadrant 2. And then we're going to do the same thing for D. D is already graphed for us. So all we have to do is identify our x value. So if I look where this maps up to our x-axis, it's at 8. And if I look at its y value at that point, it's over here at -3, right? So 8, -3 is that point. And notice it falls in this last quadrant, so it's also in quadrant 4. Okay? So I want y'all to try one. There's one at the bottom of the page here for y'all to try. Same thing, okay? I want you to, here, let me scoot this up. I want y'all to plot E and F and tell me what quadrant they're in. And then I want you to give me the point, the ordered pairs for G and H, and tell me what quadrant they're in, okay? Once you've done that, go ahead and play the video again, and we'll go over it to see how you did. All right, let's see how you did. So on the first one, when we look for E, or E is the one we're graphing, right? This means that X is at -7 and Y is at 5. So I go to the left over to -7 on the X-axis and then up to where Y is 5. So E lands in quadrant 2, okay? On number 2, we're graphing 4, 8. So both positive. So we go over to where X is +4 and then up to Y is +8, and that's where we put our F point, which happens to place it in quadrant 1, okay? And then the given points that we have here to graph, if I look for G, G is, oh, not that. Oh, I see what I did. So I swapped these. So this is actually G and this is actually H. Sorry. So on yours, your answers will probably be opposite what mine are. Okay. So when you look for G, this should be the point 5, 9, and it's in quadrant 1. I wrote that as my second one. So yours is probably on the first one. So I apologize. And then H is my second point down here, which is at -6, -2. And that makes it land in quadrant 3. So again, if you have these same, the ordered pairs in the quadrant correctly, but you have yours swapped, then you did it correctly. So I apologize about that. Okay. All right. So plotting points, obviously something we should know how to do. Hopefully not something we haven't seen before in our life. Okay. The other thing that's important to do is to determine if a ordered pair is a solution point to an equation. And the reason why we care is because every equation, for this section anyways, represents a straight line. And so if we're checking to see if an ordered pair or a point is a solution point, what we're really checking to see is that point on the given line, okay? And to check to see if it's a solution point, all we have to do is plug in its value. So here's our X value, here's our Y value of our point. We're just going to plug it into the line they give us and see if it makes a true statement, okay? So this line says to do 2 times X. So I'm going to do 2 times my X value, which is -5, plus 3 times my Y value, which here is 7. And I want to know, does that equal 18? So I just check it. 2 times -5 is -10. 3 times 7 is 21. And if I combine -10 and 21, that gives me 11, right? And 11 is not equal to 18. So because I didn't get a true statement, what that tells me is that this point is not on that line, which means it's not a solution point. I'm just going to say, no, it's not a solution point, okay? Let's check this one. This is our X, this is our Y, plugging it into the same line. So we do 2 times our X, which is 3, plus 3 times our Y, which is 4. And we want to know, does that equal 18? So if I simplify, 2 times 3 is 6, plus 3 times 4 is 12, and 6 and 12 does in fact give me 18. So because I got a true statement, that means that this is a solution point because this point is on the line. Okay, so this one is yes, it is a solution point. Okay. All right, so I want y'all to try one real quickly. There's a practice down here. Same thing. I've given you the point. I've given you the line, or in this case, the circle. And I want you to determine, is this a solution point to the given equation? Okay, so go ahead and pause the video, work it out, and then when you're ready to check yourself, play the video again. All right, so we're going to go ahead and go over this one. When you plug in -2 for our x and 1 for our y, -2 squared gives me a 4, and 1 squared gives me a 1, and 4 minus 1 is 3, which is not equal to -3. So because we're getting a false statement, then this is not a solution point, right? It's saying why or why not, because it creates a false statement. So that means it does not lie on the line or the shape created by this equation, okay? All right, so let's go ahead and move forward. The next thing I want to go over is how to graph a line using its x and y intercepts. This is a really quick and easy way to graph, but it's not the way that we would graph any line. It's only the way we would graph lines that have nice x and y intercepts. So unless it tells you to graph it using intercepts, we're probably not going to use this method. This is just a good method for when our intercepts end up nice, okay? So again, we're not going to use this method unless it tells us to graph it using intercepts, because sometimes we might get an x-intercept that's like a weird fraction, right? Or a y-intercept that's a weird fraction. It's hard to really graph those accurately. So we only want to do it when we know we're going to get nice, pretty intercepts, okay? So remember, the x-intercept is the point where it touches or crosses the x-axis. The y-intercept is the point where it touches or crosses the y-axis. So let's think about this. If we're looking at our x-axis, if there's a point that touches or crosses this line, no matter where it is on the x-axis, its y value is going to be 0, right? No matter where it is, if it happens to be on the x-axis, its y value is 0, right? And the same way with the y-intercept. If we have a point that's anywhere on the y-axis, its x value is going to be 0, right? So that's how we're going to solve for intercepts. We're going to use this idea that if we're looking for an x-intercept, we know y is 0, so we can just plug in 0 and solve. Or if we're looking for a y-intercept, we know our x is 0, so we can just plug in 0 for x and solve. Okay, so let's go ahead and look at them. Most importantly, be sure to write them as ordered pairs, okay, because they represent a point on the graph, so we need to make sure that they're written as ordered pairs and not just single digits, okay? All right, so let's look at finding the x-intercept. If I want to find the x-intercept, well, we know any point that falls on the x-axis, its y value is 0. So we're going to go ahead and set y equal to 0, right? So if I plug 0 in for y in this equation that's given, I'll get 3 times 0 plus 2x is equal to -6. 3 times 0 is just 0, so that term goes away. So I'm left with 2x is equal to -6, and then I just divide off my 2. So I get x is -3, and then I want to be sure to write it as an ordered pair. So my x value is obviously -3, and we got that by plugging 0 in for y. So my y value is 0. So that's my x-intercept, and I'm going to go ahead and plot it on my graph. So on my x-axis, I'm going to go in the negative direction until I get to -3, and there's my x-intercept. Okay, I want to do the same thing and find the y-intercept. So to find the y-intercept, any point that's on the y-axis, remember, has an x value of 0. So this time we're going to set x equal to 0. So it's a good rule of thumb. Whatever intercept you're looking for, you set the opposite variable equal to 0. Okay? So we're going to go ahead and put 0 in for x. So we have 3y plus 2 times 0 equals -6. My 2 times 0, that just becomes 0, right? So I'm really left with 3y is equal to -6. And then I divide off my 3. which gives me y is equal to -2. But remember, we don't want a single digit because we're looking for a point on the graph. So if y is -2, we got that by setting x equal to 0. So my ordered pair would be 0, -2. And then I want to go ahead and plot that point. So on my y-axis, I'm going down to -2. And now I have at least 2 points, so I should be able to draw a nice straight line through them. Okay? All right, so I want y'all to try the same thing on the next one. I want you to find the x-intercept, be sure to write it as an ordered pair, and then find the y-intercept, write it as an ordered pair, and then use those intercepts to graph the line, okay? Once you've completed that, go ahead and unpause the video and we'll go over it. All right, how did you do? All right, for our x-intercept, we're putting y, 0 in for y. So that means that my 4y term turns into a 0, right? So I get -4 for my x value. So my x-intercept is going to be -4, 0, which we plot over here, right? And then for my y-intercept, we're putting 0 in for x. So my x term is going to go away. And when I solve for y, I get 3. So that gives me the ordered pair 0, 3, which I plot the point up here on my y-axis. And then be sure you connect them with a straight line with arrows showing that it's going to keep going. Okay? All right, so we know how to graph using intercepts. Now what we want to look at is we want to graph using the slope-intercept form of a line. This is what we'll use most often, okay? So slope-intercept form of a line looks like this. This is something you're going to need to know. On an exam, I'm not going to say state the slope-intercept form of a line in a generic sense. But I may say, solve for the line, write your answer in slope-intercept form. Okay, so you need to know that slope-intercept form is y equals mx plus b. Okay, where m is our slope, right? And remember slope, this is our rise over our run. So that helps us graph it, right? How much we're rising or we're going up and down on the y-axis, and how far we're running, so how far we're going left and right on our x-axis, okay? And then b is our y-intercept, okay? 0, y. So the way that we use the slope-intercept form is we first make sure it's solved for y, right? It needs to be written in this form or we can't use this form to solve it, right? So we solve it for y, and then whatever the coefficient is on the x term, that's where we get our slope, and our constant term out here is our y-intercept. So all we have to do is plot this y-intercept and then use this slope to count over to other points. So let me show you what this looks like, okay? So on the first one, it says graph the equation. So I first want to get it looking like this. I want it in slope-intercept form, so I need to solve it for y. So I'm going to move my x term to the other side, and I do that by subtracting. So I have 5y is equal to -2x minus 10. And then I need to divide the 5 off. Now, if I divide the 5 off of this side, I need to divide it off of this side, right? But since there's more than one term, I'm going to go ahead and just write the 5 underneath each term. So that gives me y is equal to -2/5 x minus 2. Okay? So this is going to be my y-intercept. So my y-intercept is 0, -2. And then my slope is going to be -2/5. So what this tells me is that I'm going to go down 2 and forwards 5. Okay, if it's negative, we're going down or backwards, right? If it's positive, we're going up or forwards. So let's go ahead and see what this looks like. So I want to plot my y-intercept. That's going to be my starting point. So my y-intercept here is at -2. And then I count my slope from that point. So my slope says to go down 2 and forwards 5. So I go down 2 and forwards 1, 2, 3, 4, 5. And then I can keep going. I like to have at least 3 points. So down 2, 1, 2, forwards 5, 1, 2, 3, 4, 5. Okay. As long as you have at least 3 points, you should get a good line. If you want to keep going in the opposite direction, if you happen to run out of graph over here like I did, you just do the opposite of what you did. So to go to the right, obviously we're going down 2, forwards 5, down 2, forwards 5. So if we want more points going to the left, we do the opposite. So we would go up 2, backwards 5. Okay, up 2, backwards 5. Okay, and then we just connect our dots as best we can. And I'm not going to judge you if your lines aren't perfect, okay? But they should be looking like lines and not squiggles, if you know what I mean. Okay? All right, let's look at another one. Same idea here. Solve it for y first. So we're going to move our x term to the other side. So we have negative 4y is equal to negative x plus 8. And then we're going to divide off our negative 4. So we divide 4, and I'm going to write it under every single term. So that leaves us with a positive y is equal to, here a negative over a negative becomes positive. And I can write this, the number in front of the x here, if there's nothing written there, is an implied 1, right? So I can write this as 1/4 x instead of x over 4, right? And then 8 divided by negative 4 leaves me with a negative 2. Okay, so now that I have it in slope-intercept form, I can see my slope, right, which is 1/4, and I can see my y-intercept, which is 0, negative 2. Well, that's what it was on the last one. Not super exciting, are we here? Coming up with the same y-intercept. All right, so we're going to start by plotting our y-intercept, which again is at y equals negative 2. And then we're going to count over to our next point. So notice here my slope is positive. So I have a positive 1 over a positive 4. So the top represents the change in y, which if it's positive, I'm rising. So I'm going to go up 4. And then the bottom number represents our change in x, so left or right. Since it's positive, we're going to go in the positive direction 4. So from this point, I'm going up 1 and forwards 4. Oh, I have it numbered. Up 1, forwards 4. And you keep going up 1, forwards 4, up 1 until you like run off the graph. Or we can go in the opposite direction by doing the opposite thing. So instead of going up 1, forwards 4, we're going to go down 1, backwards 4. Right? Down 1, backwards 4. And once, excuse me, once we have a decent number of points here, then all we have to do is connect them with a straight-ish line, right, that hits our points. All right, so there are 2 on the next page for y'all to try. I want you to work them the same way. Solve them for y, identify the slope and the y-intercept, and then use those to graph it, okay? Once you're ready to be checked, or if you get stuck and need help, unpause the video and we'll go over them. Okay, so on the first one, to get it solved for y, we move our 2x to the other side, and then we divide off our 3. So we should get y equals 2/3 x plus 1. Our y-intercept would be at 1. So we're going to start at y at 0, 1 on the y-axis, and then from there we're going to count our slope. Since it's a positive 2/3, that means I'm going up 2 and forwards 3. So from here I go up 2, forwards 3, up 2, forwards 3, and I can keep going. Or from that starting point, my y-intercept, I can go down 2, backwards 3, right? So as long as you got a line looking similar to this, I'm feeling like you know what you're doing. Okay, let's look at the second one. The second one was already solved for you, but sometimes people get a little bit confused if it's not written in the right order. So remember, to be in y-intercept form, you need the x term written first. So all I did was rewrite it with the x term first and the constant term second. So I can see that that constant term, 2, is my y-intercept. So my y-intercept is over here at 0, 2. And then from there, I can count my slope over to my next point. And since my slope is negative, I'm just going to stick that negative with the 4. That's going to tell me to go down 4. And then positive 3 tells me to go forwards 3. So down 4, forwards 3, you can keep going down 4, forwards 3, down 4, forwards 3. Or you can start at your y-intercept and go the opposite direction by going up 4, backwards 3. Okay? Hope we're all okay on that. We are now going to move on to our last topic for this section, or at least for 1.1a. We'll get to 1.1b in the next video, but for this homework, the last topic we're going to cover on this assignment is the distance and the midpoint formula. Both of these are formulas you are going to need to know, okay? Excuse me. They will not be given to you on a test, okay? So I'm not going to ask you to state the distance formula as an exam question. I'm not going to ask you to state the midterm formula for an exam question, but I will ask you to find the distance between 2 points, and I will ask you to find the midpoint between 2 points. And if you don't know these formulas, obviously you're not going to know how to do it, okay? So make sure that these are things that you highlight, that you have on your study card. These are things you're going to need to know, okay? So the distance between 2 points is literally the linear distance. If I pick any 2 points on the graph anywhere and I draw a perfect straight line, whether it's diagonal or straight, the shortest distance between any 2 points, this is how we find it, okay? The midpoint is basically the middle point. So if I take any 2 points and I find that exact distance between them, whatever point's in the exact middle of these 2 points, right? So it would be my nose. It's directly between these two. That's the midpoint, right? And this is the formula to find that. So we're going to go ahead and go over doing a couple of examples like this and how to simplify your answer if possible, okay? So for both of these, it says find the distance between and the midpoint of the given point. So we're finding both the distance and the midpoint, okay? Now it says give an exact, well, I don't think I need that in. Give an exact answer, and when needed, a decimal approximation to 2 decimal places. So what that's talking about is not our midpoint, okay? Our midpoint, if we end up with fraction answers, we're going to leave them as fraction answers. What this is referring to is an exact answer is when we calculate this distance, let's say we end up with something like the square root of, I don't know, 13, right? The square root of 13 is not a perfect square. So the exact answer would be the square root of 13, right? But the square root of 13 is a hard thing to be able to actually draw a line that is a distance of a square root of 13. So that's why we would give a decimal approximation for that value, okay? So if you get nice, pretty answers, like if the distance ends up being 4, then you would just enter 4, right? But if it ends up being something like the square root of 47, then it will have you enter the exact answer, which is the square root of 47, and then a decimal approximation to 2 decimal places to represent what the square root of 47 actually equals, okay? All right, so let's look at these. We're first going to do the distance between these 2 points. So my distance formula, and the best thing I can tell you to do is every time you use the distance formula, say it. It'll help you learn it. So the distance is equal to the square root of my second x, okay? So this is like my first x and my first y, and this is my second x and my second y, right? So this says to do my second x and subtract my first x. So my second x is 2. I don't know why I put a negative. It's a positive 2. And we're going to subtract our first x, which is a negative 3. And then we're going to square that quantity. Okay, squared. And then we add our second y minus our first y. So our second y here is 11. Minus our first y, which is 7, and again, we're going to square that quantity, okay? So now we have it all plugged in. Now it's just a matter of simplifying. Order of operation tells us to do inside parentheses first. So inside these parentheses, all I can do is simplify the double negatives. That's going to make it positive, right? 2 plus 3 gives me 5, right? So I have the square root of a positive 5 squared plus, in these parentheses, 11 minus 7 gives me 4 squared, okay? Order of operations still tells me to do inside my grouping symbol. So inside my square root, I can't just cancel these squares because we don't have rules for addition under a square root. So I have to simplify my exponents first. So that gives me the square root of 25 plus 16. And then I can go ahead and add the 25 and the 16 together, which gives me 41. Okay, so my distance, is the square root of 41. This is my exact answer. Okay, the square root of 41, can't talk, is my exact answer. But it also wants to give me, wants me to give a decimal approximation. Okay, so if I punch this into my calculator, this comes out to be 6.4031 and some more stuff, right? So our decimal approximation, it wants us to round it to 2 decimal places. So I go to my second decimal place, which is my 0. Because there's a 3 behind it, that's not going to bump it up. It's just going to stay 0, right? So my decimal approximation would be 6.40. Okay? So this is my approximation. Okay? All right, so that's our distance formula. Now we want to look at our midpoint formula. So our midpoint formula looks like my x's added together divided by 2 and my y's added together divided by 2, which makes sense, right? Because we're trying to find that middle point. So that means we need to average our x's and average our y's so we find that exact center point, right? So when I do my first x plus my second x, my first x is -3 plus my second x, which is 2, and then I'm going to divide it by 2, and then I do my y's. So I do y1 plus y2, so my first y is 7, plus my second y, which is 11, and I divide that by 2. Make sure you're leaving it as an ordered pair, because it is a point, okay? And now we just need to simplify this. So -3 plus 2 is -1 over 2, and 7 plus 11 is 18 over 2, and then I simplify that. Okay, now -1/2 does not reduce, so we're just going to leave it in fraction form. So -1/2, but 18 divided by 2 comes out to an even 9. So we're going to leave it as 9. Okay, so this is the basic idea, right? Is just plug into the formulas. Just plug into the formulas. We're going to use this when we get into circles. You'll also see this when you get into trig functions, if you have to take trigonometry or calculus. Okay, so these are things that we will be using in the future. So let's look at another one. It's the same idea. The only difference is it has fractions, which everyone loves, right? All right, so same idea, using these formulas, but plugging it in down here. So I'm gonna leave it and so I can see the distance one, and then I'll scoot it up, okay? So if I want to find the distance, I'm gonna do the square root of my second x minus my first x. So here my second x is 1/3. So I'm going to do 1/3 minus my first x. My first x is -11/3. And that's squared. Plus, the next quantity is y2 minus y1. So my second y, which is 5/2, minus my first y, which is a -1/2. And again, I square that quantity. Okay, so I'm going to scoot this up a little bit. All right, so now I need to do some simplifying, right? Oh, my elbow keeps hitting this. Okay, so now I need to do some simplifying. So inside here, in both quantities, I have double negatives, which is going to make it positive, right? And then I need to combine a little bit. So here, 1/3 plus 11/3 is going to be 12/3, right? 12/3 squared, plus here I have 5/2 plus 1/2 is 6/2, right? 6/2 squared. And lucky for us, this actually simplifies into nice pretty numbers, right? This is the square root of 12/3 is just 4. So I have 4 squared plus 6/2 is 3, all right? So 3 squared. So I keep simplifying. So this gives me the square root of 16 plus 9. And when I combine those, I get the square root of 25. Now in this one, I don't need to leave it in radical form to have an exact answer, because my exact answer is just the simplified version of the square root of 25, which is 5. Okay, so I don't have to worry about the decimal approximation or anything like that. Okay, so now let's look at the midpoint. So our midpoint, I'm going to move my paper back up just a little bit so we can see the formula. Okay, midpoint, we're going to average our x's, we're going to average our y's. So I'm going to go ahead and put, for our midpoint, we do x1 plus x2 divided by 2. So x1 is negative 11/3 plus x2, which is 1/3. And we're going to divide that by 2, right? And then our average of our y's, so we do y1, which is negative 1/2, plus y2, which is 5/2, divided by 2. Okay, and now we just need to simplify this monster. Okay, so when I simplify on the top here, negative 11/3 plus 1/3 is negative 10/3, and that's divided by 2. And on this side, negative 1/2 plus 5/2 leaves me with 4/2, and that's divided by 2. Now this is a fraction within a fraction. We don't want to have to deal with that. So what I'm going to do is I'm going to think of this fraction line on each of these as a division, right? Because that's what fraction means, is to divide. So this one is the same thing as saying negative 10/3 divided by 2, right? And 2 I can write as 2 over 1. So when we divide fractions, remember we flip and multiply by the reciprocal of the second. So this is negative 10/3 times 1/2, right? And when I simplify this, I get negative 10/6, and then I can reduce that to negative 5/3. Okay, so this side right here becomes negative 5/3 for my middle x value. Now I want to do the same thing with this one, right? Oh, I don't even have to do the same thing with that, because 4 over 2, right, is just 2. And then when I divide that by a negative 2, that leaves me with just 1. So my midpoint is negative 5/3, comma 1. Okay. All right. So on the next page, there are 2 for y'all to try. Oh my goodness, excuse me. There are 2 for y'all to try. So go ahead and pause the video, and we want to find the distance and the midpoint of each, just like I did, okay? If it comes out to a not pretty radical, we want to make sure we get the exact answer and then also a decimal approximation for it. In your midpoint, if you get fraction answers, just leave them as reduced fractions, okay? If you get stuck or you need to be checked, unpause the video and we'll see how you did. Let's see how you did, okay? On number 1, when we do our second x, which is 3, minus our first x, which is a negative 2, my double negatives become positive, and I get 3 plus 2, which is 5. So when I square that, that gives me 25, okay? When I do my y's, my second y is negative 6, minus my first y, which is 2. Negative 6 and negative 2 gives me negative 8. When I square that, it gives me 64. So when I combine my 25 and my 64, I get the square root of 89, which is not pretty, right? But that is my exact answer. And then I can go ahead and get a decimal approximation for it. We round to 3 decimal places. And since there's a 3 behind my second decimal place, it's not going to bump it up. So our approximation is 9.43. Okay. When we do our midpoint, we're adding our x's, so negative 2 and 3, and dividing that by 2. And then we're adding our y's, so 2 and negative 6, and dividing by 2. That should give me 1/2 and negative 4/2. And when I reduce my y, that gives me -2. So my midpoint is 1/2 -2. Okay, if you need to look at that more or pause the video to go over it, please do so. I'm going to go ahead and move on to the second one. Okay, same thing. If I go fast and you need more time, feel free to pause it at any time so that you can go through it at your own pace. Okay, for number 2, I'm doing my second x, which here is -3/5, minus my first x, which is also -3/5. Okay, and then in my second quantity, I do my second y, which is 2/3, minus my first y, which is -4. Okay, so notice here, when I change my double negatives into a positive, these are opposites, right? So those just combine to 0. So this whole mess right here, that's just going to go away, right? Over here, I combine my double negatives to get a positive, and now I need to combine 2/3 and a +4. So I'm going to write that as 4/1 and get a common denominator. Okay, to get a common denominator for these two, it would be 3, which means I need to multiply this one on top and bottom by 3. So when I multiply the top by 3, that gives me 12. When I multiply the bottom by 3, that gives me 3. So this is the only quantity that's going to be left under the radical here. And now that I have a common denominator, I can go ahead and add the tops. So that gives me 14/3. And notice it's 14/3 squared, right? And that's all that I have under my radical. So here my square and my square root are going to cancel. If you didn't notice that and you squared 14 and got 96/9, and then you took the square root of it, either way you're going to end up back at 14/3. So this is considered our exact answer because it is a fraction that it actually doesn't turn out pretty, right? It repeats and goes on forever. So if it asks for an exact answer, we would enter our reduced fraction version of it. And then for our decimal approximation, we would go ahead and do 14 divided by 3, see the decimal, and then round to 2 decimal places, which should give us 4.67. Okay. On the next one, to find our midpoint, we're adding our x's and dividing by 2. And then we're adding our y's and dividing by 2. Okay, when we add our x's, they already have common denominators, so we get -6/5 divided by 2. And then I went ahead and wrote that out as a division. Sorry, that glare. Let's see if I can put my hand there. There we go. All right, so -6/5 divided by 2. I flip the 2 and multiply, so that gives me -6/5 times 1/2, which becomes -6/10, which then I can reduce to 3/5. So this whole first coordinate, this is me simplifying this whole first coordinate down to figure out that our midpoint x value is -3/5. Then I want to do the same thing for the y. Before I can combine these, they need a common denominator, which again would be 3. So this one needs to be multiplied on top and bottom by 3, which would give me -12/3. Now that they both have a denominator of 3, I can combine it, which gives me -10/3 divided by 2. So again, when I write it out, -10/3 divided by 2, I can flip and multiply by the reciprocal. So -10/3 times 1/2, which gives me -10/6, and then that reduces to -5/3. So all of this work right here was to simplify the y value of my midpoint, which ends up being -5/3. Okay? All right, so that is the end of section 1.1a. So you should be able to complete that assignment now. If you have any questions, please feel free to ask me.